most comprehensive preparation app for all the competitive exams. So today I am going to discuss minimization of DFA. So how to draw the minimized DFA for a given language, and also if a DFA with more states are given, how we can reduce the number of states. And marking algorithm also I will explain with small example. So all of you please join quickly and please let me know whether my audio, video, everything is clear. Okay. So if not, please do let me know. I hope I am audible and visible to every one of you. Okay. So we are going to discuss about how to draw the deterministic finite automata with the minimum number of states. Okay. Am I audible and am I visible? And you can just say hi or hello in the chat box. I'm very happy to see all of you once again. So before I begin the session, I wanted to introduce myself. Most of you might be knowing about me. Myself, Murali Krishna Bokasamudram. I'm having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I'm topper of NPTEL course in theory of computation and also certified as international engineering educator through ISRO certification program. And I have mentored more than 50,000 students across the country in different core areas of computer science. Those are theory of computation, TOC, operating systems, OS, computer organization, COA, computer networks, CN, digital logic design, DLD, and information and communication technology, ICT. So these are the areas where I'm familiar with and expertise with areas. And now let us start the session. Before that, if you have not yet subscribed the channel, please do subscribe it. We are offering a GATE Rankers Monsoon series. It's a free course in the YouTube. Please do subscribe right now for availing the benefits. Most important topics of electrical, electronics, and computer science. It will be starting from 10th July. Okay. All the faculty of computer science and other branches also will be attending for it. And now coming to there is a scholarship test, national level scholarship test for GATE exam. It is on 9th July at 9 a.m. You can register right now for it and you can get up to 90% off if you do well in the exam. If your performance is good and you get a good marks, then you can take a step towards success in the GATE exam by availing this benefit. Okay. I hope my audio, video, everything is clear. Please confirm me once and please do share the class information with your friends. Am I audible? Is my audio, video, everything is clear? Okay, just say hi or hello. Okay, now let's start the session. And this is a topper strategy to secure all India rank under 100 in the GATE by Joshit Singh sir. It is on 11th July at 7:30 p.m. You can register right now for it. And minimization of DFA. So what do you mean by minimization? Actually, when you're implementing DFA, if the minimum state DFA is implemented, it's more effective. It occupies less memory and also we can access that entries very fast. Okay. So these DFA minimization will be used in the lexical analysis phase of compilation. If you take any DFA, in a minimization, an existing DFA gets converted into equivalence DFA with minimum number of states. There won't be any change in the language. For example, M1 is a DFA before minimization and M2 is a DFA after minimization. Some states are reduced. Then language accepted by M1 is the same as language accepted by M2. So both machines must accept the same language. There should not be any change in the language. I hope you understood. And another thing is, if two or more states in the DFA are found to be equivalent, then those states can be combined into single state. Okay, for example, if you identified something like, let us suppose P is one state and Q is one state, R is one state. And if you found that the state P is equivalent to state Q, which is equivalent to state R, then PQR can be clubbed into single state. But the thing is that how to identify equality in the states? Usually equality may exist among only the final states, among only the non-final state. One final, one non-final can never be equivalent. That is a fundamental rule. I will also explain that rule through the help of example. Okay. I hope my audio, video, everything is clear. And please do share the class information with your friends. Are you sharing? And also please do like this session and let us see the minimization process. If two or more states in the DFA are found to be equivalent, then those states can be combined into single. all equivalent states belonging to either final or non-final set of states. One final, one non-final can never be equivalent. For example, if you wanted to define what is the equality, two states P and Q can be equivalent. So we can say that P is equivalent to Q if and only for all x belongs to sigma star. Whatever the string you take in sigma star, transition of P comma x is in final state means Q comma x also must be in final. Or if a transition of P comma x is in a non-final state, Q comma x also must be non-final. So that means either both must be in final state or both must be in non-final state. So then only we can say that state P is exactly equivalent to state Q. So we can combine PQ into single state if they are found to be equivalent. But for all x belongs to sigma star, we have to verify means sigma star may containing infinite number of strings. So finding the equality of states by using the direct procedure is almost impossible because infinite number of strings we can't verify. For every x, for all means whatever the x value you take, transition of p comma x it goes to final state means any final state, not necessarily be the same final state both are. F is set of final states and q comma x also must be final. If at all if p comma x is in non-final, then q comma x also must be non-final. If these conditions are satisfied for every x belongs to sigma star, then we can say that state P is equivalent to the state Q. Otherwise, it is distinguishable. If any of one x value if condition is failed, then we can say that they are not equivalent. So we can't combine them. Okay, it is example. So distinguishable are inequivalent or unequal states. Two states P and Q can be unequal. That means P is not equivalent to Q. If and only for any x belongs to sigma star, transition of P comma x is in F, then Q comma x must be Q minus F. What do you mean by Q minus F? Set of non-final states. Q minus F is nothing but set of non-final states. And F is nothing but set of final states. And Q is a total set of states. So non-final states Q minus F. Or if P comma x is in Q minus F, Q comma x must be in F. If these conditions are satisfied, then we can say that it is distinguishable for any one x value. So identifying inequality is very simple. For instance, P is a non-final state, Q is a final state. That means P belongs to Q minus F, okay, and Q belongs to F. And we can prove that P is not equivalent to Q because one final, one non-final can never be equivalent because x may be any string in sigma star, right? For example, if I take x is equal to epsilon, so transition of P comma epsilon, it will be in P only. In the DFA, there won't be epsilon transitions. So without giving any input, it will be P only. And the transition of Q comma epsilon is in Q only. So P belongs to Q minus F and Q belongs to F. So we can say that P is not equivalent to Q because it is satisfied the condition. So this definition clearly states that one final or non-final can never be equivalent. It doesn't mean that all final are equivalent. It doesn't mean that all non-final are equivalent. One final or non-final may be equivalent. It's always inequivalent, one final or non-final. But equality may exist among the final states or among the non-final state. Not guaranteed. That we have to verify. But a pair containing one final, one non-final is directly known to be distinguishable. It is directly known to be distinguishable or directly known to be inequivalent or unequal. Okay. Hope you understood, right? Okay. Now coming to marking algorithm. Marking algorithm is meant for making the cross mark for the inequivalent states. Okay, so step 1 in marking algorithm, mark all the pairs in the given DFA which are directly known to be distinguishable. A pair containing one final, one non-final is always distinguishable. If you find out the pairs which are distinguishable and the pairs which you cannot show as distinguishable can be taken as equivalent pairs. Okay, step 2 you can see. For example, if any pair P comma Q, so they are not directly known to be distinguishable, means both are in final states or both are in non-final, for example, P and Q. That is the meaning of if it is not directly known to be distinguishable, then for any input A belongs to sigma, not for all. For any input, not X. For any input A belongs to sigma, not in sigma star. Input alphabet of a DFA. Transition of P comma A is going to the state R and Q comma A is going to the state S. If RS is already known to be, the pair RS is already known to be distinguishable, then P comma Q also can be taken as distinguishable. Okay, so if the pair RS is known to be distinguishable, then marked. Distinguishable means marked, they are not equivalent. then we can mark P comma Q also. Marking is nothing but just cross mark saying that they are not equivalent. The pair P and Q cross mark means it is not equivalent. Okay. Now step 3 is repeat the S2 for all the pairs which are not directly known to be distinguishable. We can mark the pairs which are directly known to be distinguishable. That means one final, one non-final. And if the pair is containing both final states or both non-final state, you have to verify the step 2, repeat the step 2 for every pair of like that. Okay. So after doing that, then what you have to do is whatever all unmarked pairs, those are considered to be equivalent pairs and combine them. And then afterwards, repeat the step 1 to 4. After combining them, you will get, for example, we are checking the equality among two states only. Pair means two states. But if there are four states, for example, PQRS, in one iteration, you found that P is equivalent to Q. Then PQ will be clubbed. Okay, R and S still they are not clubbed. And R may be equivalent to PQ. That in the next iteration it will come. So in every iteration, pair containing two states. If two or more states are equivalent, we have to repeat the process for example, 4-state DFA minimize it to 3 states. Again, on the 3 states, we have to repeat the steps 1 to 4. Okay, now? So I will explain this concept once by using the example so that it is very easy for you to understand. Okay, now? Is it clear? I hope every one of you have understood. Nobody is responding actually. So some of you please say hi or hello. You are not having an access to the live chat box. I'm unable to understand. Nobody is responding. Please respond so that I'm able to understand now. Okay, that's great. Okay, shall I move? Okay. And if you are not yet been subscribed, so please do subscribe the channel and also please share the class information with your friends. Okay, now let's move. Marking algorithm is done. So I am taking an example. See this example. Example of DFA minimization. Consider DFA accepting a language something like this. For example, ABCD. Okay, so ABCD actually the pairs actually AA pair we don't consider. Actually, diagram we should draw like this. Diagram should be drawn like this. For getting the pairs. Okay. How to draw the pairs? I am just letting you know. For example, we are having A, B, C. Just a moment. I will. Okay, what are the pairs? So in this diagram also we can do it. Anyway, in the next page it is available. I will show you. So what is the delta here? First write the delta. This is the given DFA. A and B are the inputs. Okay, and states are A, B, C, D. And what is the final state? B. B is the final state. In the set of final states, we have a B. Okay, in the set of non-final states, that is a Q minus F, we are having A, C, and D. Am I right? So S indicates it's a starting state. A is a starting state. A on A, it goes to D. A on B, it goes to B on A, it goes to C. B on B, it goes to B. C on A, it goes to D. C on B, it goes to B. D on A is D, B is D. So like this, we can construct the delta. Delta is a transition function with initial state as A and final state I am putting a star mark, it is B. Okay. Now there is one direct method of doing it and also indirect method. First, I will let you know how to do the marking technique. So in a marking technique, we have to go with a pairs. What is the first step? If you see what is the first step of marking technique, mark all the pairs in a given DFA which are directly known to be distinguishable. When can you say that a pair is directly known to be distinguishable? A pair containing one final and one non-final state. A pair containing one final, non-final. For example, I am considering this is a pair AB. AA pair is not applicable actually. This is AC. This is AD. And BB is not applicable. And this is a BC. So AB, AC, AD, BC, BD. and CB or BC both are same, it won't come. Okay, and here CC will not come, but CD will come. Okay, na? So these are the pairs. So we can say 1, 2, 3, 4, 5, 6 pairs will be there for 4 states: AB, AC, AD, AB, AC, AD, BC, BD, and CD. These are the pairs. AD also came. So what are the pairs? Now I am giving you a diagram. This diagram actually we have to leave the first state in the vertical and the last state in the horizontal. So it is BCD and this is ABC. This is only for getting the pairs. This is for pair AB. No, you have to leave the last state, right? Just a moment. I will just get back to you once. It is not like that. What we have to do is we have to write ABC on the vertical. In the horizontal line, you can write, leave the last state. Only ABC you write. In the vertical, you write BCD. So that AB is a pair AB, AC, AD, BC, BD, and CD. So first step, as per the first step, a pair containing one final, one non-final can be marked. So you can see. So AB, B is final, A is non-final. It is directly known to be distinguishable. Cross mark, they are not equivalent. And AC, AD both are non-final. They are not directly known to be distinguishable. Okay. Next, BC, B is final, C is non-final. So it is marked. BD, B final, D non-final. So it is marked. So AC, AD, CD are the pairs. They are not directly known to be distinguishable. Second step is applicable. What is the second step? AC. So in the case of AC, second step, if you see, second step is as you see, you can see. For any pair P comma Q, if it is not directly known to be distinguishable, then for any input A belongs to sigma, if transition of P comma A is R, Q comma A is S. If RS is known to be distinguishable, we can mark P comma Q also. So directly in the diagram, I will show you here. Okay. So now AC. Now I am seeing AC. For AC, for any input, for input A, we got DD. For input B, we got BB. So DD, BB pair will not exist. So AC we can't mark. And AD. For an AD, we got DD for input A. For input B, any input, BD. BD is marked. That's why AD can be marked. Now you are getting CD. CD on input A, DD, on input B, BD. Any of these pairs. So BD is marked. So we can mark the CD. And AC can't be marked because DD, BB is not a pair. So we can confirm that we are not able to prove their equivalent, their distinguishability. So that means we can consider this A is equivalent to C. When A is equivalent to C, we can club AC into single state like this. When A is equivalent to C, AC can be clubbed into a single state, and B still it is a final state, and D is a non-final. And how can we define the transition here? So A on A is D. A on A, it is D. Okay. And A on B, it is B. And what about B on A? B on A, it is a C. B on A, it is a C. Okay. And B on B, it is a D. And D on either A is D or B is D, like this. So it has been minimized from 4 states to 3 states. And we can also check whether further minimization is possible or not. Once again, I will tell you, BCD, it is ABC. Once again, I am telling you, AB is directly known to be distinguishable. Okay, and BD and BC, these are not directly known to be distinguishable. AD pair, we have verified now. So these are marked, and this is unmarked. Okay, na? So when it is unmarked, we can again apply the marking technique for this. Okay, I will apply again marking technique. For example, AC is there and B is a final state, and the only one iteration is over. After one iteration, we found that A is equivalent to C. What are the transitions? BA, B and A. and this is B on B is D. AC on A is D, and D on either A or B is D. Now again I will apply marking technique for this. So if you apply marking technique, so we can do like this. We can give a diagram like this. This is for BC. Leave the first state. Okay, and we get only 3 pairs for the 3 states. So AC is one state and B is one state. Just a moment. It is not like this. Hope you are following, right? Now we can take this is AC and B. This is B and D. So B final, AC non-final. So AC and B is unmarked because they are not equivalent. Because one final, one non-final. B final, D non-final. Now AC and D. AC on A is D. D on A is D. And AC on B is B. D on B is D. So BD is marked. So we can mark. All are marked. All are marked means no further minimization possible. No equal pairs again. So that we can confirm that there won't be minimization further for it. No equal states. All are distinguishable. So that there is no further minimization possible for it. And if you wanted to do directly, I will tell you. Directly how to do, I am telling you one trick. Listen carefully. So when you draw this delta for the states A, B, C, D, okay, A on A is D, A on B, it is B, B on A, it is C, B on B, it is C on A, it is D, C on B, it is B, B on A is D, B is D. Now if you see vertically, actually there is a pair DB, DB is equivalent. DB, DB is repeated for two states A and C, which are both are non-final. If it is repeated for one final, one non-final, we can't club them. So DB, DB repeated for a pair A comma C. So AC can be directly clubbed into single state, and B will be this one. And further we can reduce some iterations. This is a simple way. And another example also I will tell you. So simple way. I will give you as a homework. You can try this simple way for it. So minimize this DFA with the 6 states I am giving you. A, B, C is the final, D is the final, and E is the final, and F is the non-final. Okay, so A on 0 is B, B on 0 is A, and A on 1 is C, and C on 0, E on 0 is E, D on 0 is also E, and D on 1 is F, and E on 1 is F, and C on 1 is also F, and this is 1. So this is a DFA. So every state has taken 0 and 1. F is a dead state. 0 or 1 going to the same state. Now you just continue your discussion on the comment box regarding how many states we can get after minimization. So one trick I wanted to tell you. So same trick you can use. So before you begin the solution, I am just giving you the trick. So 0 and 1 are the inputs here. A, B, C, D, E and F. And set of final states are C, D, E. And set of non-final states are A and B and F. A, B and F. Hope you are following. Now A0 is B, A1 is C. And B0 is A, B1 is D. Okay, and C0 is E, C1 is F. D0 is E, D1 is F. E0 is E, E1 is F. F0 is F, like this. Now we can do, actually there is a pair EF, EF, EF repeated for 3 states. And luckily all the 3 states are final. We can combine them. So C, D, E are equivalent. Directly we can do without going to minimize this marking algorithm also. Lot of iterations we can save. Then A, B, F are separate states now. Again, you apply marking algorithm for A, B, F and C, D, then your job will become easy. And please discuss this in the comment box after this class is finished. And please first spend some time, and if you don't get, please ask me in the next class. I hope you people have enjoyed the session of marking technique for minimization of DFA. Okay, thank you so much. Thank you, one and all. See you. Bye bye. Meet you again tomorrow at 10:15 and the problem solving on regular languages in the tomorrow's class. And still, if you have the doubts, you can just ask your doubts. Thank you so much.